Thank you for tuning in to The Second Brain Box, a podcast with a mission to share insights from experts about the science behind our gut bacteria, brought to you by Yakult Science.
Hello, my name is Rafaela and I'm the Science Communications Intern at Yakult. Today, we are joined by Professor Glenn Gibson, who is a Professor of Food Microbiology at the University of Reading, and his current research is dominated by gut microbiome interactions and dietary intervention. In our last episode, we spoke about the fundamental roles of the gut microbiota in supporting our gut health and immunity. But there is also a lot of research investigating the potential roles beyond this, which we will be discussing in our podcast episode today. Can you share with us what are some of the emerging roles of the gut microbiota?
Gut health is something long-standing which has been associated with the microbiome. That's why there's been a lot of research over the years on IBS, ulcerative colitis, Crohn's disease, gastroenteritis, atopic issues. But I think the two big ones are obesity and the gut-brain axis of cognitive function. And it's incredibly exciting that really good studies have been conducted, looking at the role of the gut microbiome in these issues. The whole area of weight management, obesity, risk of type 2 diabetes, looking at appetite regulation, satiety, which hormones are involved in these, whether the microbiota can influence these hormones. And then the gut-brain. I mean, I never thought when I started researching this area would be in the situation where metabolites made by the gut microbiome can have such a systemic effect and influence cognitive function, mood, and all sorts of other things are on the agenda. It's very, very interesting.
I definitely agree. And what was the earlier research within this field that really got us looking into these potential roles of the gut microbiota?
So the two that spring to mind are the original work from the USA, Washington University, where the group looked at differences in the gut microbiome profile of obese and lean people. And those studies have been repeated with kind of varying results, but I think there's a general consensus that the microbiome does differ and that therefore influences appetite and satiety, the feeling of fullness. And the good thing is, like our genetics, our gut microbiome can be changed. So if the gut microbiome is an additional risk factor in obesity, it's something which we can address and alter in a relatively straightforward manner. So along with the other messages of diet, exercise, etc. But, I often feel that with obese people, I feel really sorry for them because the last thing that needs to be done is lectured about physical activity and their diet. And I do feel that the gut microbiome may offer another possible route to assistance, should that be desired. The other one goes back a long time. There was this clinician called Arbuthnot Lane, who I think lived in the late 1800s. And he was famous for suggesting that the gut microbiome was involved in migraine and schizophrenia. And actually nobody believed it. And so he passed away and his sort of predictions were not really taken that seriously. And where we are today, it actually looks like he was right. And a whole load of issues are being looked at, from subclinical anxiety to clinical anxiety to depression, autism, dementias, Parkinson's, and so on. And it's hugely interesting. And the strength of it has been, again, collaborative, because like the metabonomic revolution, where biochemists have got interest in this area, the kind of psychological revolution has been with psychologists and psychiatrists also getting interested. And they've brought really novel and challenging skills into the microbial field. And I think the future, the next 5 years in these two aspects of obesity and cognitive issues is going to be absolutely fascinating.
Most definitely. A lot of the findings in this field have been based on animal and in vitro studies, though, but there seems to be a slowly increasing amount of human data too. Are there certain roles that are clearly also supported by the human data?
I think you have to test things in vivo in humans if it's a human issue. I mean, I can't really see much point in working on autism in mice and obesity in rats. I think you really need to do it in the definitive area which you are interested in. And the same goes for livestock. If you're interested in cattle health or sheep or chickens or whatever, or horses, it should be done in those. However, in vitro studies. I'm not a fan at all of animal studies. I must say, I don't think there is really any good animal model for humans. Humans walk around on two legs and most lab animals don't. And therefore, straight away, there's a difference in the anatomy, diet, all sorts of things change. But in vitro studies can be useful from the point of view of helping to plan what could be done in vivo, to use models of the gut, which we've built in our lab. And these can be infant, elderly, adults, certain clinical states like IBS, autism, obesity, colitis, whatever we're interested in really, and test dietary profiles in these, the effects on the microbiota, and also interventions like pro and prebiotics, and then move to human studies after that. And really, I think the in vitro studies are ways in which you rule things out rather than in. So if something doesn't work well in vitro in a lab, you probably wouldn't go to the human trial. However, if it works in the lab in vitro, that means you still have to do the human trial to get the final proof. And so that's my kind of view on what's gone on. And I think the field has really been very dominated by animal model research. And as I've already said, I'm not a fan of that at all.
You've brought up some interesting points. The link between the gut and the brain is a very popular topic at the moment, even among the general public. Can you explain the concept of the gut-brain axis?
I can try. Well, the human body is not just kind of thrown together. The human body is built and has evolved for a reason. And if we look at what happens between the gut and the brain, those two organs are linked by the vagus nerve. And there must be a reason for linking the vagus nerve between the gut and the brain, because, as I said, the human body doesn't just come together for no reason. So that really points to the ability to put it in the simple sense of talking between the gut and the brain. For instance, if you feel nervous, you get butterflies. It's said to be in your stomach, but it's not really in your stomach. But anyway, that's a gut manifestation of nerves. And similarly, if someone is constipated, they often get a migraine or a headache. And so those two go hand in hand. And one of the more common intestinal ailments, irritable bowel syndrome, does have a link to stress. And so that's where it began to be built. But now people are doing very sophisticated tests, psychological assessments in conjunction with gut microbiota alterations to look at a whole range of, as we've talked about, cognitive issues. And what my great friend here, Bishma, who's in our psychology department, we've just started this month a 5-year program sponsored by the European Union to look at MRI scanning of the gut and the brain in the same people. And we're going to be feeding probiotics and prebiotics and seeing whether we can match patterns which arise in the gut with those in the brain. MRI really works by giving off heat. And so you can see these patterns in situ in people. So, we're looking forward to that. We've got a great postdoc already on the project. We're looking for another one. We've got the gut side of it covered. We're looking for someone on the psychological side of it. So, so I think that's going to be great.
That's very exciting. I look forward to hearing and reading more about your project. What have been some of the most interesting publications within the gut-brain axis field?
To me, I really admire the work from Cork. So that's Ted Dinan and John Cryan and their groups. I mean, they're absolutely hilarious people to meet and great fun to get on with, but they're brilliant scientists as well. And they've really pioneered this. They've looked at the role generally of probiotics in issues like anxiety, depression. Same kind of thing counts for Phil Burnett at Oxford. He's done some excellent work, largely on prebiotics, actually, looking at, again, depression. He's looked at various dementias. I think it was actually Parkinson's he's looked at as well. And so these kind of skills that people bring in accurately monitoring the psychological outputs are absolutely fascinating. The same goes for Andy Smith and his group at Cardiff. So, and Andy has done some fantastic work on cereals and showed that people genuinely do feel more energized when they've taken in cereals. And, we've often believed this to be the case. Have a bowl of cereal in the morning, you'll feel better about the day ahead of you. But he's actually proven it. And Andy's theory is that organic acids made in the gut, mainly acetate, are responsible for this. And so, it's fantastic. I mean, in a series where, you look at something like, and this is something Phil Burnett told me, that subclinical anxiety in the UK is millions and millions of people. So these are poor people who are absolutely fine sometimes, but all of a sudden they get very anxious about something. and it's not reached the state where clinical intervention or clinical advice is required. So effectively, they're left to manage this alone. And if we can begin to unravel the potential role of gut microbiome in this and alter the situation, that could be fantastic news moving forward. And the same counts for the other clinical states we already talked about, like depression, autism, and dementias. And the idea is that the gut microbiome makes positive and negative factors which can influence at the level of the brain. And some of the examples of these are things like GABA, acetate. Gary Frost in Imperial has shown that acetate produced in the gut can be metabolized actually partly at least by the hypothalamus of the brain and begin to affect appetite and hunger sensations as a result of that. I mean, this is absolutely fantastic stuff. And again, goodness knows what the next few years will bring, but the real aim is to try and come up with interventions which are safe, efficacious, alter the microbiome, and do have this systemic effect upon cognitive challenges. And the skills people have brought to the area are absolutely fantastic to help in that regard and actually show genuine mechanisms of effect, not just that something happens, but why it happens.
I definitely agree. And do you think that maybe one day we will be consuming specific foods to support our mental health?
I think that's not far away at all. The Koch guys have pioneered the psychobiotic area. I think there are possibly even products available now, but I think it's going to expand. And yes, I think that is certainly going to be the case over the next few years. What we've talked about previously in the podcasts about getting the information across, because the science can be done, it can be published in good journals, it can be reproducible. Not everything works. About half of the experiments we do in our labs in Reading don't work out. And that's the case, I think, on average for science generally. But the things that are important and could improve consumer health, I think we really need to unravel this issue of getting the communication correct. It has improved. I think nowadays people maybe believe that bacteria are not all harmful and can do some good, and we really need to capitalise and build upon that. And the whole area of health claims and what we can say on products about the research that has been done in a user-friendly manner really needs to be addressed more thoroughly and robustly in my view.
You've brought up some interesting points. Just very briefly, what do we know about the role of the gut microbiota in our metabolic health?
So again, this relates to appetite regulation, the hormones which regulate appetite and fullness, and what potentially the microbiota could do. There's also another story that if you get more fermentation, which is breakdown of food ingredients by gut bacteria, you get less calorie exchange. So if you fortify your gut microbiome, there may be less of a calorific effect. I think that is the case. And then there's another angle to this of something called LPS, which is lipopolysaccharide. This is part of the cell wall of gram-negative bacteria. Patrice Canny, Nathalie Delzen in Belgium have shown that LPS can onset something which they've termed a metabolic endotoxemia, which is very similar to what type 2 diabetes does in the gut. So it's effectively inflammation. So if you can reduce levels of LPS through fortifying gram-positive bacteria at the expense of the gram-negatives, that's another angle related to the whole issue of obesity, type 2 diabetes, gut inflammation, and most probiotics are gram-positive. And so again, it opens up the rationale or the role for using pre and probiotics. And yes, that is being done. And again, I think we're looking at ways in which we can modulate gut health with this systemic issue of weight management and risk of obesity. So obviously, the traditional messages of diet and exercise count for a lot, but I think this is one additional factor which can be built into the picture.
And what about cancer and the gut microbiota?
There is some, I guess, little bit of tenuous evidence that breast cancer may be involved, but clearly it's going to be mainly digestive cancers like bowel cancer, stomach cancer. There's been a link with Helicobacter pylori, a stomach bug. It's meant to be involved in ulcer formation as well as type 2 gastritis, potentially stomach cancer. But further down into the large intestine, the gut microbiome can make about 10 different types of carcinogens from the diet. And these are awful words to get our heads around, but things like fecapentines, nitrosamines, diacylglycerols, IQ, these are examples of very toxic metabolites produced in the gut. On the contrary, dietary fibre, the production of organic acids like butyrate is said to be protective. Phytic acid is also said to have some kind of protective capacity. So again, it's a balance. And I think it's the case for all the possible conditions that we've discussed in the podcasts, that there is a negative and a positive contribution by the gut microbiome. The key challenge is to unravel which components of the microbiome are respectively involved in those two tracks and do something about it, either through natural diet or through the use of supplements. And I know that people who know a lot more about nutrition than me will say, well, you should really only go for the natural route, the 5 to 8 pieces of fruit and vegetables. I think we all agree with that. But in some cases, I mean, I personally don't have any issue with additional pro and prebiotics in the diet. And I've taken them myself for donkey's years every day and will for the foreseeable.
That's great. We've talked about just a few potential roles of the microbiota, and hopefully we will go into far more detail in further episodes. But just to end this episode off, what do you think the most interesting potential role of the gut microbiota is, and why?
It has to be the area of gut-brain, which fascinates me the most. That's really what I'm learning about from people like Bishma, Ted, John, Phil at Oxford. I mean, they're really bringing these excellent skills to the table. And, I just sit there in awe listening to what they have to say about all of this. So I think it's probably the area I know the least about. But most scientists are inquisitive, and that's where huge opportunities do arise in terms of really consumer health and welfare, but also my own biased learning curve.
Well, thank you so much, Glenn, for giving us an insight into some of the emerging roles of the gut microbiota.
Thank you for tuning in to the Second Brain Box podcast, brought to you by Yakult Science. For more information and to sign up for future episodes, go to yakult.co.uk/HBB.